So the geometric series, the sum in sigma notation. So we're looking at the guided practice. So you had questions to complete and we'll just go through the answers. So question 5a. So if we look for we need to find the first terms. We need to find a1. Let's write that, find a1. And we need to find the ratio and we need to find n. So a1 is the first term. So to find the first term, we need to substitute k equals 4 into our formula. So a quarter times 3. And if k is 4, we're going to put 4 minus 1. And we're going to work this out. So this will be 6.75. So this is our first term. So a1 is equal to 675. Now we need to find the ratio. So the ratio is the base. So the ratio is the base. So this is going to be 3. So 3. And then we need to know n. So we need to know n. So the number of terms is going to be the difference. So 12 minus 4 plus 1. So n will be 12 minus 4 is 8 plus 1 is 9. So let's just write this here. A1, this is 6.75. The ratio is 3 and n is 9. And we can use this into our formula. So we're going to use Sn is 6.75 minus, actually let's write the formula down first. So Sn minus, is equal to A1 minus A1 r to the n divided by 1 minus r, where r is not equal to 1, otherwise we'll have an undefined value. So now we'll substitute in. So Sn, A1 is 6.75 minus 6.75, r is 3 and it's to the power of 9. So 6.75 minus 6.75, 3 to the power 9 is 19683. And this was divided, that's not, it's divided by, let's go back, that should be divided by 1 minus 3. So Sn is 6.75 minus 6.75 multiplied by 19683, and this is divided by minus 2. So let's just work out the numerator. This would be minus 132,853.5, and it's divided by minus 2. So the sum of the numbers is 66426.75, or 66,426.75. Okay, so if you look at 5b, I've just rewritten the question, and we need to find a1, r, and n. So to calculate a1, we're going to substitute in the value k with 2. So that's 2/3 multiplied by 4, and that's 2 minus 1. So a1 will be 2/3 multiplied 4 to the 1, so that's just 4, and this will be 8/3. The ratio is the base value, and the ratio here we have 4, so the ratio is 4. And to find the number of terms, we need to do the difference. So 9 minus 2 plus 1. So n is 8. So writing down the formula. So Sn is a1 minus a1 r to the n divided by 1 minus r. And we substitute in the values. So Sn is 8 over 3 minus 8 over 3 multiplied by 4 to the power 8 divided by 1 minus 4. If we work out the numerator, that'll be 8 over 3 minus 8 over 3 multiplied by 65536 divided by minus 3. And I'm going to put that into my calculator, and that's minus 174760 divided by minus 3, and that's 58253.3 recurring. So I'm just going to write a few 3's. Okay, so looking at example 6, this is finding the first terms of a series. And we're asked to find a1 in a geometric series for when we're given that the sum of the numbers is 13,116, the number of terms is 7, and r is 3. So we need to find a1. So we're going to use the formula Sn is a1 minus a1 r to the n, and substitute in the values we know. So we know that Sn is 13116. We don't know a1. We know the ratio is 3, and we know that we're raising to the power of 7 because n is 7. What we can do is factor. So we're going to factor by a1. So we'll have a1, so that's 1 minus 3 to the power 7. And I forgot to do the divide, so this is actually dividing. So let's go back. This is divided by 1 minus r. So let's try again. So a1 minus a1, and we know the ratio r is 3, and that's the power 7. And Sn, okay, so we got that. And we're dividing by 1 minus 3. Okay, so the sum of the numbers we can replace with 13116. And we're going to factor, so let's write that by here. Factor by a1. So a1, and that's going to be 1 minus 3 to the power 7 divided by minus 2. So I'm just going to work 13116, and this is going to be equal to a, so let's multiply, so 1 minus 3 to the power 7 is minus 2186. So I'm going to write this the other way around. So I'm going to write minus 2186, and I'm going to write a1. And this is divided by minus 2. So if we divide by minus 2, 13116 is equal to 1093 multiplied by a1. And now if we divide both sides by 1093, A1 is equal to 12.